Okay, sorry. Good morning. Thank you for coming. And I saw about 15, 20% of hands have already used Redshift. And how many folks have already been to one Redshift session? All right, so then I will go through my intro section very quickly. We all know, you all know at this point what Redshift is. And really what we built it for was high-performance data warehousing that was easy to use and extremely cost-effectively priced. And what we've seen as a result of this has been a real expansion in the number of use cases for which data warehousing can now be used. So it's not just traditional enterprise data warehousing. We're also seeing a lot of big data-related use cases, as well as SaaS applications where Redshift is embedded under the scene, providing analytics to end customers. Architecturally, Redshift is a clustered system. It's got a leader node, which is your SQL endpoint. That's where you connect your applications. And the leader node is really responsible for coordinating query execution across the entire cluster. Everything's interconnected. Your compute nodes, which is where your data is stored and query processing takes place, they're connected to the leader node and to each other and to S3 using 10 gig E connections for high-performance inter-node communication. And we also have a single node variant available where all of these are co-located to give you a low-cost dev test environment. And the pricing that you're looking at here is for that single node price point. This node has 2 terabytes of compressed storage on it. And we have 3 pricing models. In an hourly pricing model, it's under $1 an hour, which works out to an annual cost per terabyte all in of just over $3,700. And then we have a 1-year and 3-year reservation model where you can commit to those terms and get a 40% or a 70% discount in return for doing that. You're not charged for the leader node. It's just the number of compute nodes that you have in your system and the size of those nodes. There's 2 sizes, one at 2T, and then the other one, which is 8 times larger at 16 terabytes per node. And that is, on an hourly basis, 8 times the cost. But because it has 8 times the storage, the cost per terabyte's the same. And also, just before we get started, I'd like to introduce our speakers, if you guys don't mind standing so folks can see who you are. We've got Jason Timmies from NASDAQ, Kevin Diamond from Outlook, and Parag Tucker and Colin McGuigan from Round Arch Isobar. Jason, it's all yours.
Thank you. See, is my mic on? Yep, great. All right. So just quick introduction. My name is Jason Timmies. I'm an AVP of software development with NASDAQ OMX. And I know stereotypically NASDAQ is seen as old school Wall Street conservative, so it's definitely a technical conference. I figured I'd go casual for this one, so there we go, casual, good. Just briefly to talk about NASDAQ, because most of you know us as an exchange. I mean, a household name in the US, but that's what you think of. We're actually much more than that. So NASDAQ actually runs 26 different markets that we operate ourselves. And globally, we actually sell our technology to other exchanges and markets worldwide. And so our technology actually powers over 70 marketplaces in 50 countries. And overall, we end up handling about 1 in 10 of the world's securities transactions. So this is our business. We know it well. The rest of that, I'll just let you read. So what do? Really, I'm basically the development manager around our FinCloud offering, which is a strategic partnership between us and AWS to really try to bring financial services to the Amazon public cloud, right? So financial services has historically been a little bit slow to adopt public cloud. There's definitely a lot of scrutiny around security and a lot of concern there. And NASDAQ went through a very extensive vetting and believe we can trust it. And so, we're bringing our brand to that and trying to create an ecosystem by which the whole industry can really adopt it and leverage those economies of scale. In addition to that, it's become extremely attractive internally for us. There's a lot of cost savings there, the same reasons why you all are using it. And so there's a lot of internal projects now looking to leverage the Amazon infrastructure versus our traditional on-premise stuff. And that's really what I'm going to talk about today is one of those internal projects. So the challenge that we're trying to solve is archiving market data. So what is market data, unless you're in my industry? It's really a stock ticker on steroids, right? So any of the financial channels, you turn to it and you see all the little stocks scrolling by with all the prices. Imagine several multicast feeds that are that information in real time, right? What is every symbol buying and selling at across every exchange as fast as you can get it. And really, these are the inputs into all of the trading algorithms that do most of the trading in the US today, right? So computers take that in and decide what to buy and sell, and it's a race to see who gets their order there first. Why do we want to archive all of that? It really comes down to what we call surveillance, but it's knowing what's going on in the market so that we can both do our own BI on that and make intelligent business decisions around how we price things and where we focus. But also, specifically to the surveillance side, there are certain trading patterns that are illicit or prohibited, and we have an obligation to essentially police our own market and know if that activity is going on. So there's regulatory compliance drivers behind this, as well as just operating our business and optimizing our own revenue. And of course, we have the same challenge every other IT department has. We want to minimize cost, right? So you're all interested in Redshift because it's cost-effective data warehousing. Well, guess what? That applies to us too. And standard Amazon sort of sales pitch, it involves less human labor on our side, right? More of it's automated. What used to be a call to IT and a ticket and waiting for it to get scheduled and prioritized and worked on is now a web service call, and the answer's there. And last, a real theme for this particular project is we wanted to empower the business for self-service. So as you're going to see in our, it's one more slide down. As you'll see, there's the legacy solution that we had where anytime they needed something new done, it was really a ticket to development, and then they had to wait because we're resource constrained. We work on a bunch of different things. We'll get to it when we can. And it goes through prioritization and all of that. But if we could create an architecture where the business users with a little bit of training could do that stuff themselves, they can get their answers faster, the data's more accessible, and we can make better decisions and operate more efficiently. So that was a real driver for us. That went the wrong way. All right, so just to show that market data truly is a big data problem, you can see in the large white slide, these are really some average volumes around message counts for monitoring the entire industry. So UQDF is really just a way of saying market data for all of the NASDAQ listed securities. CQS is really just a way of saying all of the stuff listed on the New York Stock Exchange. We need to watch all of that. So we've got an average daily volume there of about 500 million messages a day. The table in the lower right, Opera, is a way of saying watching what's going on in the options industry. The top table is equities. And you can see options orders are even crazier. It's a little bit volatile, but let's say about 4 billion messages a day. In June, we were seeing closer to 8, but billions per day, right? And then the gray table is just watching a more detailed view of every order on the NASDAQ exchange. And again, we operate several exchanges, but NASDAQ's the one everybody knows. It's the use case I went with. It's the big dog. So watching all of that, it's about 500 million messages a day. You add all of that together, it's a lot of data, right? And we want at least a year online and in Redshift. And for some of this data, we actually want 3 years of it around. So it adds up quick. So briefly to talk about what we had before, and frankly, I'm not going to name names because I'm not here to trash talk anybody. I'm here to talk about what we're doing that's new and cool. But the legacy on-premise MPP database, standard on-premise solution, right? Relatively expensive, finite storage. When we run out, we have to go buy more. There's lead time there. It's not elastic. It's not a web service call away. So you got to plan, you got to watch, you got to budget, and there's a whole group of humans dedicated to the care and feeding of that thing, right? So all of that translates to money. And then our legacy BI tool, again, anytime they needed an enhancement, it's a ticket to development, whether that's a new data source, a new report, a new dashboard, whatever. So slower. So what did we end up doing? Obviously, we brought in Redshift. To speak a little bit to how cost-effective it is, even if we started day one with matching the exact same storage capacity of our on-premise solution, which we're not doing, right? But had we started with just provision it all up front, we're still only 43% of the cost of our existing infrastructure budget, less than half. And the real story is even better than that because we can start small and just add nodes as we need to. So we actually started with just 2 8XL nodes. And in fact, we're still on 2 8XL for the moment. But by the end of year one, we project we're going to be at 7. And we budgeted assuming that we were paying for 7 for the entire year. So there's a theme here. I like to underpromise, overdeliver. And so by saying, hey, here's the cost, it keeps my spreadsheet simple, frankly, right? So there's a laziness factor there. I come from a development background. But here we go. And then when the real costs end up being even lower, everybody's happy. So, and that doesn't even include the IT human costs around it. This is just infrastructure. So the overall story is really, really compelling. Performance, we've been very, very pleasantly surprised, frankly. So we assumed going virtual, going in Amazon, that it would be good enough, but that it would probably be maybe a little bit slower than what we had before. In practice, we're actually finding it's faster, which is just icing on the cake, right? So one of our real big analytics guys, he's a big fan of R, so we ended up giving him just direct access to the warehouse with a read-only credentials. And the first day that he got to go in and play, I literally got an email from him in all caps. It just said, "Oh my God, best database ever." So it's always nice when your customers are happy, right? So I actually forwarded that one to Rahul. It was good. Just to give you one metric around that, we're seeing insert performance on the order of over 500,000 rows per second. And that's just on a 2-node cluster, right? We can scale this thing up if we need to. So that's great. And the last one, the point of it being elastic, it's easy to use, right? So again, rather than having to do a lot of upfront capacity planning, by just watching it and having some metrics around that, we can optimize our spending and only dial it up as we need it. On the BI side, what are we using to sit on top of this warehouse? I already mentioned R, but for most of our users, we did a bake-off and we actually ended up selecting Pentaho. So I wanted to give them a shout out. They are an Amazon Redshift partner. Got the link there if you're interested. And Pentaho really fit with our goal of achieving self-service. So it includes an ETL tool as part of the overall picture. So rather than having to go buy Informatica as well as this, you kind of get all in one package at a very attractive price point. So there's the cost effective. But again, with a little bit of training, the users can go in, they can connect up new data sources if they have some Excel spreadsheet they pulled down that they want to add in and add that to the model, they can do it. If there's some other database that we haven't added to the warehouse yet, because we have a lot of data laying around legacy, they can do it. And in the beginning, of course, we're going to send them to a little training. We're going to help them. It's not magic, but they don't need to know how to code either. It's very visual. It's very drag and drop. They can learn, and then they can do it themselves, and they can get access to that data faster. They can create their own reports and dashboards very easily. This screenshot here is actually from their version 4.8, which is what we used up until now. We've actually got version 5.0, their new release, which came out around Labor Day. We're installing it this week, so I look forward to playing with it when I get back to the office. But they've improved the visuals quite a bit. That was an area where they had gotten some feedback from their customers. And since we were going with an internal tool, we were more interested in the capabilities than the eye candy. But if that matters to you, it's something that they've certainly focused on and addressed. So what does all of this mean, net result, right? The new solution is cheaper, it's faster, and it offers better capabilities to our business users than they had before. So there's really no downside to this. They're able to get in there and explore the data. We've reduced the dependency on IT and development, so we're free to go do new things, which excites us more. Who wants to sit around and maintain a data warehouse, right? And if any of you are doing that, my apologies, no offense intended. And overall, we are NASDAQ. We're a very numbers-focused organization. It's margin improvement, right? I just told a story that both lowers my bottom line costs, and because we're making faster, better decisions, hopefully we're raising the top line a little bit. So that's what it's all about. So thank you very much.
Hi, how's everyone doing? I'm Kevin Diamond. I'm the Chief Technology Officer for Outlook. Generally, I talk at kind of e-commerce and retail and fashion conventions. So when I say Outlook, everyone would know what I'm talking about. I assume probably for this crowd, you might not have heard of us, but that's okay. I oversee all of our technology, our infrastructure, data, engineering, so kind of everything falls under me. But my major focus is on the customer experience and how we prove that that's what the customer is actually experiencing. So I'll tell you quickly what Outlook is. We do private sale. It's kind of known as the members-only, limited-time sale events. It's all around premium fashion, lifestyle brands, exclusive prices, 50 to 75% off. Every single day, we do over 20 new sale events. They all start at 8 a.m., so we get kind of the almost the Black Friday effect every single morning at that time. And we have over 14 million members. And in 2011, we were acquired by Nordstrom. So first off, I want to talk about why a data warehouse. So we have data in a lot of different places, and that's the common story when you're talking about building a data warehouse. So we have our custom in-house applications that were built on MySQL. All of those run on different servers. We have our ERP platform, our financial system, that's running on MS SQL. We run our own fulfillment centers, so we have warehouse management systems. Those are running on MS SQL. We also get data from all sorts of random sources, whether it's iTunes Connect or wherever else. And we wanted a place where we could see all this data, mesh it all together, and be able to run analytics off of it. So we knew we needed a data warehouse. But also we knew that we needed to put together a data model around how you would look at this data. And that was the bigger part of the challenge, because it's how do you look at kind of the operational reports versus the analytical reports, essentially the real time versus the previous day. So we looked at a bunch of competitors when we were trying to decide on who we were going to choose. And you know, I as well didn't want to name names, but we definitely saw a huge difference in price when you start talking about Redshift versus the other people in the marketplace. But even bigger was everyone else required us to buy software, to do a big implementation, to buy a ton of hardware, really big hardware, put it in a data center, pay for the power and the, you know, the connectivity and all that kind of stuff. And we didn't want to do any of that. So we decided, why even bother with the RFP? Let's just go with them, figure it out, see whether it works. So we jumped into public beta, and we never looked back. So for us, the implementation has been the hardest part, but that's because of our data. So we built from the ground up a MySQL database. We didn't think about things like, oh, let's put a create date on a record. You know, that might be helpful. So the biggest piece was how do you do the ETL out of MySQL? On the Microsoft side, it was far easier because all those packages had that kind of stuff ingrained into it. But we ended up getting a direct connect line, and we do kind of data dumps on a daily basis right now into S3. Those are flat files. So we do iTunes Connect, our web analytics, our log files, on top of all the other stuff that we do. And then we used AWS Data Pipeline. Essentially, we use Scoop, which is an Apache project, along with Hadoop. We run that on EC2, and that loads all the data into the Amazon Redshift. And kind of our data model around that is kind of the star schema concept, which, if you're not familiar, looks something like this, where you have facts and dimensions. But obviously, it's important to be able to actually look at what data you're storing. So we chose a business intelligence tool, MicroStrategy. They're a partner with Amazon on this. We unfortunately had difficulty deploying them into the cloud. That was half on us. And so we ended up just putting them on-premise, which is not ideal. We hope to be able to move that later on. But even having them on-premise and our data in the cloud, it still works amazingly well. And it was so easy to tie into Amazon Redshift, just using their ODBC drivers. The way MicroStrategy works is it kind of utilizes metadata. All of that we had to put into an MS SQL database. Hopefully in the future that can also live in a place like Redshift. But we were able to get rid of all of our old legacy SSIS, SSRS, random MySQL and Excel reports that were all over the place, and move all of those that are based around the analytical reports into MicroStrategy. So this is kind of what it all looks like. So we go from our data center, where we have our MySQL and our MS SQL databases, over a nice direct connect line, into our exported data onto S3. The Amazon data pipeline executes the jobs that run Scoop and Hadoop on EC2. That processes the data to get it into the format that we actually want to see it in, and that's what loads it up into Redshift. And then we go across the internet back to our local servers where we're running MicroStrategy and to the local client's desktop. So we don't have a ton of data, definitely not as much as NASDAQ is running on. Most of ours is around the sale of goods. So we have less than 2 terabytes. But at first we thought, well, hey, let's go with the big 8XL. It sounds cool. They're awesome. They're huge, you know, to get great performance. And so we spun up 2 kind of in a failover fashion. They are a little bit more costly. Granted, as Rahul mentioned, that's you're paying for what you get. It does scale to the bigger size. But for us, we didn't really need that. So we decided, hey, let's run a comparison test of 6 XL instances in a cluster versus essentially this one 8XL. And we actually found that for majority of our queries, it actually performed a lot better. But really, that shouldn't have been surprising for us, because everything else we do is based on the cluster concept of how do you scale out, not scale up. So really, if you don't have the data, if you don't need more than the 2 terabytes that the XL instance offers, definitely recommend going that route versus going up to the big 16 terabyte 8XL instances. So for us, the firsthand experience, ETL was definitely our hardest part, but Redshift has been performing great. The one biggest factor that we have is no one really has a great SQL tool out there yet. I heard last night about one, so I'm excited to try it out, because I don't want to pay the hefty licenses for a SQL tool that'll actually run on it. MicroStrategy works great. Again, I wish it ran on EC2, but it's running great on our on-premise platform. And you know, going across the internet to grab the data has not been an issue, which is pretty incredible. And we're saving a ton of money. So I put a huge budget line item last year for building out a data warehouse, and a big piece of that was hardware. Didn't have to spend $1 of that. So I got to buy other cool stuff. So there's no hardware cost, there's no maintenance, none of the overhead. And the annual costs are equivalent to just the maintenance on most of the data warehouse products that you see out there. So not even counting the initial costs. So in conclusion, some advice. Only use the 8XL instances if you actually need the additional power and the additional space, which in our case, we didn't. Buy reserved instances, obviously, although we still have yet to do this, but it'll save you even more money. That's how you get down to that kind of $1,000 a year per terabyte. We probably could have used MapReduce instead of just putting Hadoop on an EC2, but we didn't. Oh well. We'll be taking a look at that soon. Almost all BI tools will run on Amazon Redshift, which has been great. So choose the one that's right for you. For us, being a retailer, MicroStrategy is pretty much the top of their game. And the communication between your AWS and data center is easy as long as you get that kind of direct connect line, and it's incredibly fast. And we are owned by a big public company, so it had to go through the whole information security policies and all that kind of stuff, and as Jason was saying, it passed with flying colors, so. Great, I'll go ahead and pass it over.
Good job, man. Hi guys, I'm Parag Thakkar. I'm the Vice President with Roundach Isobar. I run the Big Data practice, and I have with me Colin McEwen, who is our data architect, the Big Data practice. So who are we? Think of us as like an enterprise digital agency. We build enterprise class digital experiences for our clients. So it's a UX, data, and technology. Think of us bringing us all together. Sorry about that. Here's the work we did for US Air Force since 2001. It's one of the largest portals in the world managing the logistics for the Air Force. So we can visualize all their airplanes everywhere in the world, and we pull all this data together and we can help visualize for the Air Force. Here's the work we did for New York Jets, which helps them in game time, in real time, analyzing all their stadium operations, all their assets, how are they doing, so they can optimize their business. Here's the work we did with financial institutions, where we can help create sexy dashboards to help them analyze the data for the investment managers. So being part of the digital agency, and we were recently acquired by one of the top 5 advertising companies, Aegis, we work with a lot more CMOs than CTOs or CIOs. And what do you think is their focus today? Big data to them is more of a technology term. They are more interested in what can this do for me? Can it help me answer my questions? So we believe CMOs are focused on optimizing their marketing spend. They are spending money in advertising, but they want to see, if I'm paying so much money for my advertising, what does it help me with what I own, which is my websites, my mobile applications, and what I earn in social media. So they are looking at bringing it all together so they can streamline their operations. That's the focus of CMO. They don't care about big data. They care about what can it do for them. So we are more about taking that technology and applying to make it make sense for them. So if you look at the marketing domain, billions of dollars in spend, lot of media channels, hundreds of data sources, multiple terabytes of data, and we specialize this across, we look at this across multiple clients, retail, government, healthcare, financials. Everybody has the same problem, but in different ways they look at it. So you're talking about all these channels like web, mobile, display, search. You've got to bring it all together and make it easy for them to understand. We see this effectiveness coming in 3 stages. First stage is analysis. Get all this data together in a big data platform like Redshift, centralize it, and build simple analytics tools that an end user can see it easily, or an analyst can see it easily. So first stage is analysis. Then the next stage of maturity is learning. Once you have the analysis done, once you have reporting done, you got to find those nuggets of opportunities. Oh, I wish we had done this here. I wish we had had this campaign run in this way. You find those areas of optimization, and then you look at, okay, how can I make those recommendations so I can optimize? So you have modeling solutions, what if conditions, scenarios, things. So that's the second stage of maturity. And then comes the true optimization. Some optimizations are done in real time. So if you have a real experience right now, like on the website or on the search platform, you make those optimized real time. Some optimization can be done to improve your operations, like media buying, reporting, planning functions. You do real-time bidding, DSPs, or you can do the adjustments of your experience with A/B testing. So to me, optimization has a lot of opportunities. But the end goal of this is you take from analysis to learning to optimization, and we build a platform that has all the solutions in each of the stages. Because to us, if you don't get them to the optimizations, it's all useless. So we have an application that we built on the platform called Scorecard, which we're going to talk about. Then we are building applications like Sonar and Compass, which help them discover areas for optimization and modeling. And then we have solutions that is real-time search experience improvements, listening to what users are saying and optimize their experience. Because we believe that the old days of defining the user experience upfront are gone. It's all going to be data-driven user experience going forward. So what we have accomplished? So we built a marketing analytics platform called Radar to enable in-time analytics and reporting and optimizations, all the 3 stages. We wanted to build a platform that can do all these 3. For one of the top clients out there, Macy's, GM, Pfizer, and if you look at those guys, those are the top spenders out there. So we built a platform assuming all those data sets into a thing, and we wanted to make sure they're customizable for each client with their own metrics and their own way of looking at business. We are dealing with 200+ feeds, a terabyte of data a week, various frequency. Some data comes every day, every second. Some data comes in weekly, monthly, various granularity. Some data is at the transaction level. Some data is at the placement level. Some data is at the campaign level. So various granularity, various classifications. And we had to build a multi-tenant SaaS platform on Amazon. So that's what we did. And we did it in 3 months with the first launch. Obviously, we are now optimizing it and bringing on new clients, but the first launch was done in 3 months. Thanks to Redshift, we got it up and running very quickly. So here's an example of a dashboard. This is one of our retail clients where they wanted to see the data in their own way. They are very focused on geography. So this is an example for Macy's, Gillette, where you have to make sense of the data, not from how it is coming, not at the transaction level, but at the campaign level or the event level or the job level, the way business wants to see it. So they are more interested in like maps. They love maps. Everything is geography-based. Taking that data and tying it to the geography and say, how is this region doing for my sales, for my advertising, how much I'm spending and what I'm getting for it, how much is the web traffic, how much is my social media going up and down, so they can see it all together. It's all about bringing it together. So here's the logical architecture. So we are taking data from various sources like display, which is Google DFA, search, Google, Bing, organic search, traditional SEO, digital videos. Every client has a custom digital video offering, site metrics, Google Web Analytics, because that's our own channel. You can get mobile traffic and web traffic, sales data. This is everybody has a different way of getting the sales data. TV, radio, print, those are the advertising platforms. Competitive. This is another big thing. Everybody wants to also see how my competitors are spending, so I know how much I should be spending, or how my competitors are doing. So we get data from like solutions like Kantar and stuff from GM. And then we get social, paid, and earned, and we bring it together all in a big data warehouse. We started with Hadoop, then we moved to Redshift. And then we believe there's 2 ways to look at reporting. Reporting, there's traditional BI, which has been there forever. So we want to support that traditional BI. We don't care whether it's MicroStrategy, Tableau, Pentaho, it doesn't matter to us. We want to support, and all of them work on Amazon. But to us, if you don't make it sense to the executives or the marketing organizations, it's useless. So we build a solution called Scorecard, which takes the granular level data and maps it to what makes sense for them. That's the hard part. As I said, we have multiple sources, so we are dealing with voluminous data, individual transactions. Every ad you see, anybody sees, individual transaction, we collect that. UGC data, geospatial, weather, sales. Then we look at the digital performance data, which is search, which is at a different scale, different granularity, different grain. Then looking at campaign level data, because at the end of the day, businesses are creating campaigns. So taking all the different various slices of data with various granularity, we bring it all together. And I have Colin walk you through a technical architecture behind this.
Hi, my name is Colin McWigan. I'm the technical architect for Round Arch Bar, and I will walk you through in a little bit of a lower level what we did using Redshift. This is an overview of the technical architecture. I'll go through each of these points in a little bit of deeper detail, but if anybody wants to take a picture, I will. So we receive as Parag said, a number of different feeds from a number of different sources. We do a lot of work in getting those feeds into flat text files, which we put onto S3. We use S3 as our file data store. We keep the files on Glacier in case that we need to recover or reload them. In any case, we don't use Redshift backups because it's a tremendous amount of data. With the files on S3, we load them on predetermined schedules depending upon how we get them. Sometimes we get files every month, sometimes we get them every week, sometimes we get them every hour. We have got different jobs for every file. They all get loaded through a Pig script to clean and format the data for loading into Redshift. The Pig script does things such as validation, ensuring that number fields are numbers, that we've got some sources that like to send them in exponential notation, which Redshift won't take. They need to be in a decimal format. So we do all of that cleaning on Hadoop using Pig. We put the clean files back onto S3, and then we load them into Redshift using copy statements. This works incredibly well and is literally the simplest ETL job I've ever worked on. Once in Redshift, we've got the data, we've got it in the client's format. We allow business analysts either inside of Round Our Chess Bar or inside the client themselves to connect to Redshift using the VPC and their BI tool of choice, the popular one being Tableau. This, again, solves a number of problems for us without actually requiring any work besides setting up the VPC. If someone's analysts want to be running their own queries, it does not impact our performance noticeably, and it makes them happy, and everybody wins. In order to make the data useful for people who are not analysts and don't have Tableau, we aggregate it to higher levels. Usually this is to a campaign level. It depends on client. They might want to track their marketing spending by department, or by campaign, or by job, or by brand. We have a lot of metadata gathered from the client that we also store in Redshift. We store it in Redshift so that we can easily run SQL queries that join their client data against the metadata to produce usable results for them. We have, for each client, we have a set of queries that we'll run through and we'll take their data for a specific time period. We'll join it using standard SQL joins to their metadata and output it into temporary tables, which we will then write out to S3. We take those outputs written out through S3 through simple unload statements. We load them into our actual end result database, which is MySQL, using MySQL import. And that allows us to move on to the next step. New slide. We do all of this using a number of tools. We use Jenkins to do the job control when we need to schedule a job so that imports run every hour or every day. That is done through Jenkins so that we're only notified on failure and we don't need to worry about it. It does email alerts. In general, if there's a problem, it tends to be on the data side that the client sent us bad data or some not our fault problem. Ruby is the scripting language that we use to actually do the work. You could go with anything. We went with Ruby because our needs were relatively simple. Most of the work being done was in SQL in Redshift. We use DynamoDB in order to do state storage for these jobs so that we know which jobs are running, how long they took, various metrics such as that. Finally, with the results of the client SQL outputted to S3, loaded into MySQL, that is what our actual website runs on. The screenshots you saw before of the scorecard application do not go against Redshift directly because Redshift, unfortunately, does not provide sub-second response time, which we need for the website to be considered usable. So we pre-aggregate that data, we put it in MySQL because in pre-aggregated form it is much smaller, and then the website runs against MySQL. We've got our clients going through, we run our website using Java on EC2, which is all within AWS. DNS is done through AWS. It all works really well. So the reasons that we, and personally I, love AWS is that it allowed us to do all of this incredibly quickly. I'm used to dealing with other companies where having to do things such as setting up a huge 32 terabyte cluster would take weeks all by itself without anything else. Using Redshift, it was set up within a day, and we were up and running with our proof of concept within 2 weeks. This enabled us to get to market really quickly, to come back to the client and do very agile development so we could show them, here's what we've got, here's what we've got, here's what we've got, every step along the way. The operational overhead has been lowered. We don't need to be paying for IT people to be racking this. We don't need to be paying for data center costs, actual server costs, and Redshift and EC2 costs are very competitive. And it's highly scalable. When we need more storage, click a button, wait 15 minutes, done. Don't need to go through any process, and it's almost as fast as getting a cup of coffee. So I will now return it back to Parag.
So key learning from all this thing is, data is definitely important, but if you don't have the right metadata, you cannot make use of the data. To us, we got to find the right metadata to make sure we can make sense of the data. We have to make sure in the cloud world, you got to think about scalability up front. The routines you write, the logic you write, you have to think about scalability up front and how your application is going to scale with the large set of data you're going to get. Always, we felt like there are always better ways to aggregate. In Redshift, in anything, if you're dealing with very complex logic, you always have to be lookout for, are there other technologies out there, other options out there you can do this better? Because we believe this is the area where it's going to be getting really better and cheaper in the long haul. With Amazon, one thing that we learned is cost management is super critical. You will make mistakes. Your first month's bill will be very high. You'll be like freaking out. But then over time, you'll figure out, okay, if you do this in this way, the cost can come down. And Amazon is very good about that. I mean, we first felt Amazon would like to have our high cost, but they don't. They really want to help you reduce your cost. So I think this is one of the things that you will realize over time, that you will have people focused on how you bring your cost in control. Build agile. We believe in agile development. Don't boil the ocean. Try to do small slices, but do end-to-end. Prove out your architecture on a smaller data set, and then scale it up. This model works beautifully in the Amazon cloud world as well. From our perspective, since we believe in large-scale enterprise architecture, in this world as well, we kept data visualization, data cleansing, storage, data aggregations, all those components of the architecture separate, so that we can tweak and make each of them better over time. And again, as I said, if you're dealing with different Kubernetes, it's very complicated. You've got to think through how you're going to bring the right aggregation routines in Redshift with the right metadata and be smart about it. This is where I think the majority of time is typically spent. You've got to bring it all together. That's all we have. We open to any questions? Thanks, everyone.